Hello. So in this video, we're looking at how we can use partial fractions to help us expand kind of complicated expressions binomially. So it was kind of about how we would take something like this, which is quite complicated looking, split it up using partial fractions. So hopefully you know how to do partial fractions from the previous chapter. And then once you split it up, we can expand each of these terms individually, and then we can combine it all so we end up with like a binomial expansion. So to see how we do that, let's take a look at part A here. So this one says expand this whole thing in ascending powers of x as far as the term x squared. And fortunately, they've already expanded this for us. So sometimes you'd have to do this yourself. Like you'd have to take something like this and then use your partial fraction knowledge to expand it to this. But we've already been given that in this question. So the first thing we need to do, if we want to expand this, is actually express what we're given in a form that we can actually do binomial expansion on. So at the moment, you can't binomially expand this. So what I've done is I've taken this bit here and I've just rewritten it with powers. So rather than x plus 2, I've written that as x plus 2 to the power of minus 1, because you've got to bring this bit to the top. And similarly over here, rather than taking away 2 over x minus 3, I've put the x minus 3 to the power of minus 1. Then all I've done between these two lines is I've swapped these two around. So you know normally when you binomial expand something, you have like the 1 plus something x. You don't have the x plus the number. So I've swapped these around, and same here, I've swapped the x and the minus 3 around. And then what I've done is I pulled out a factor of 2. And remember, when you pull out this factor, you've got to keep the power. So I've got a 1 here, and here I've pulled out the factor of minus 3. So remember, when we do binomial expansion, you have to have a 1 plus something x. So that's what I've done for these two. And then I just simplified that down a bit. So this is a half, and minus 2 times 1 over minus 3 is 2/3. So we've now got this all in a form that we can actually binomial expand. That's the first thing to do. Always put it into this form first. And then the second thing to do is use binomial expansion to actually expand these terms. So if we look, let's scroll down a bit. The 3 is just going to stay as a 3. Yeah, that doesn't change at all. But then this bit here, I got to think my x is x over 2. You don't have to write this out, but I always like to write this out. And my n up here is this minus 1. So I keep this half. Yeah, this half here stays on the outside of the bracket. And then in big square brackets, we need to expand this. So our first term would be 1. Second term would be x over 2 times minus 1, so minus x over 2. And then so on, we expand all this. Remember, you get given the formula for this, so you don't have to remember. We do the same thing here. This 2/3 comes to the outside, and then we expand this with the knowledge that x is our minus x over 3, and our n is minus 1. So expand all that. Once you've done that, you then simplify that down. So all I've done in this row is expand, we simplify these, and multiply them all by their half. And then same thing here. And finally, once you've expanded everything, you then simplify it all by adding or combining your like terms. So you get 25 over 6 plus 1 over 36x and 43 over 216x cubed, sorry, x squared. That's it. So there we've done part A. We have expanded this in ascending powers of x. So the last bit we need to do is just state the set of values of x for which the expansion is valid. And this again is basically just like any other binomial expansion. We need to find the validity of each individual part of the expansion. So what I've done is I've just rewritten out the question, but in the form that I'm going to binomial expand. So these all look like binomial expansions. And then remember, it's this bit here which is important for the validity. So because there's an x over 2, we know that it's x over 2 modulus, which is less than 1. So we can multiply both sides by 2 to find that modulus of x is less than 2. So that's what's going to be valid for this one. Then we check this one as well. And we have this minus x over 3 is less than 1. The minus just disappears because it's in a modulus sign, you don't have to worry about it. Then you multiply both sides by 3, and you get that the modulus of x is less than 3. So you've now got kind of two validities. You've got x has to be less than 2, and x has to be less than 3. Well, the more restrictive one of those is that x is less than 2. So that's the one that we have to go with. So overall, our expansion will be valid values when the modulus of x is less than 2. And that's it. That's the whole thing done. So hope that all makes sense. It's really just mostly using the information and knowledge from the previous topic about how to expand things binomially. The only thing it adds in is just how to split up something quite complicated into multiple things that you can then binomially expand. So if you have any questions, let us know down in the FAQ. Otherwise, have a go at the MCQs at the end of the topic for this. And I'll see you in the next video. Thanks.